Okay, good morning. So let me solve you some problems from the book. So we learned about the squaring rule. We learned about the conjugate rule, and then let us solve some of the problems in the book that might be somehow related to these. Okay. I will choose some, and then we'll teach the new lesson. So here. Let me choose some for you. Okay, so problem 2083. This is exponent to CS. So 2083. So let me, for example. Yeah, let us solve all of these parts. They are simple, but let us practice. We are supposed to simplify the following expressions as much as possible. Yes? So, the expression is this. So, 3a squared plus 2 times a plus 1 squared. I know the questions are very simple, but let us try to practice a little bit. So if you want to simplify this expression, you need to understand the priority of the operations. Yes? So if I want to do this operation, hopefully you know that the power has the first priority. So I have to do this one first, and then multiply this to the result. And then this is already done, and then I add these two. So that is the way that we have to do it, yes? So then it means that I have 3a squared. For the time being, I cannot do anything with 3a squared, so I put it here. Then I will have plus 2. But now we know that this is the squaring rule, so we can use that, yes? So what is the squaring rule, do you remember? The first term squared, this is the important part. 2 times the first one times the second one, which becomes 2a. 2 times a is 2a times 1 is 2a again, and then plus the second one squared. Okay? And then what I have to do now, I have a multiplication going on, so that is the priority. So I would just write it like this. I will copy and paste the first term, which I cannot do anything with that. Then I multiply 2 in. It becomes 2a squared plus 4a plus 2. Yes? And then you see that I have similar terms involved now. I have to simplify as much as possible. So it becomes 5a squared, 3a squared plus 2a squared. And then I have plus 4a plus 2. That is the answer that you have to provide. Is that clear? Okay. These examples are simple actually. But let me, to refresh your memory, do all of them. You can also get involved with me, yes? So part B, I am supposed to calculate this a plus b squared plus a minus b squared. We want to simplify that. Of course, we have 2 squaring rules, so we'll know the rules. So a pair of brackets for the first one plus a pair of brackets for the second one. I expand the first one here. This is the first one squared plus 2 times the first one times the second one plus the second one squared. And then next one becomes the first one squared 2 times the first one times the second one, but the second one is negative, so this becomes negative 2ab. The second one squared, even though the second one is negative, but when I square it, it becomes positive. And now I have to remove the pairs of brackets. So here I don't need to be worried about, there is nothing behind this pair of brackets. And here that's positive, so I can just safely remove that without any changes, yes. Then you see that this term and that term are similar but opposite, so they are totally gone. A squared, another a squared, it becomes 2a squared. B squared plus b squared is 2b squared. So that would be the answer to this. Any questions here? Okay, so let me solve next one. Part C, you have this. You have 2x plus 1 multiplied by 2x minus 1, and then minus 2x times x plus 1. You have to be very good in these kinds of simplifications and things like that. They are very simple. Okay, here, of course, I can start multiplying term by term, but I will really recommend you to train your eyes to catch the patterns as much as possible. Yes? So hopefully, of course, I told you that you can multiply and the answer at the end will be definitely correct. But can you detect any kind of pattern here? Yes?
It's conjugate pattern.
Yes, the first two are actually forming a conjugate pattern. Why? Because I have two terms involved. One of them is called 2x, the other one is 1. Once they are added, once they are subtracted, and I want to multiply them. Whenever this occurs, it means that that's a conjugate pattern. Yes? So what was the formula, what was the answer to the conjugate pattern? So this becomes, if you remember, the first one squared, I really recommend you to do it in your head. So what's that? It becomes 4x squared. Always and always minus in the conjugate pattern. The second one is 1 squared, which is 1. And then I multiply this minus 2x in. Be careful, this minus 2x, this minus sign will affect this one as well as this one. So this becomes minus 2x squared minus 2x. And now you see that there are similar terms involved, this one and that one. So this becomes 2x squared. You can write minus 1 minus 2x, but I prefer to write it in an organized way in a descending order of the powers. That's not compulsory, of course. You can write minus 1 minus 2x, but I prefer to write minus 2x minus 1. Yes? Is that clear? Okay, the next one, let me also solve that. Part D is actually a 6x squared minus x plus 2 squared. Okay, how should I do that? I have to expand this one first, because I have subtraction and power. Of course, the priority is with power, yes? So I will copy and paste the first one, and minus. I open a pair of brackets to write the answer of this expansion inside it. This becomes the squaring pattern. So it becomes the first one squared. 2 times the first one is 2x, times the second one becomes 4x. And then the next one squared is 4. Now time is to remove the pair of brackets. So this becomes 6x squared, and I have seen students make mistake. This minus sign is not only for the first one, but for every term inside. So I have to write minus x squared. Be careful, minus 4x and minus 4. And now this term and that term are similar, so this becomes 5x squared minus 4x minus 4. That is where we stop. Yes? Okay. Now, actually, there is another problem. You are supposed to solve equations. I want to write them here for you and then wait a little bit, okay? So that you can give me the answer. But some of them are very simple, so I ignore them. I think it's a good idea to solve the part B, C, D of exercise to 2086. So 2086. So this is part So let me write, solve. You see I am using the word solve the equation. So this is the equation. Let me start with part B. I want to wait for you, okay? 2x plus 7, they are very simple, but try to use the patterns as much as possible and you see. Don't just start multiplication. Of course it will work, but don't get used to this way of thinking. So by the way, solve the equation. It's not an identity. You are supposed to find the appropriate value for x so that the left hand side for that value of x becomes equal to the right hand side for the same value of x. Okay, I will pause recording. I don't know if there is anyone on the Zoom. Yes, so people at home, if you want to work on the problem, please take notes, because when I pause the video you will not be able to see it anymore. Thank you. Do not use multiplication method, use patterns. If there is a conjugate pattern, use it. If there is a squaring pattern, use it. Okay, do you have your answer now? No? Might be it's a good idea if I solve the first one myself. So you can help me, yes? If I want to solve this equation, I have to simplify it as much as possible. And then on the left-hand side, hopefully you detect some kind of pattern, and on the right-hand side, also a pattern is involved. So what pattern is involved on the left-hand side? It is clear, the conjugate pattern, yes? And then I have the the squaring rule. So this becomes the first one squared, which is 4x squared, minus the second one squared is 49. Yes? And then on the right hand side, the priority is with the power, so I have to keep 2, I have to keep 4, and I have to expand that. So this becomes the first one squared, 2 times the first one times the second one. 2 times the first one is 2x, times the second one, which is minus 5, yes? You have 2x multiplied by minus 5. So the answer is minus 10x. And then minus 5 to power 2, which is positive 25. Okay, that's the first step. The second step, I cannot simplify anything here, so I have to copy and paste it. On the right hand side, the priority is with the multiplication. This is addition, this is multiplication. So don't write 2 plus 4, because this multiplication should be done first. So it means that I expand that by multiplying 4 inside. So it becomes 4x squared minus 40x plus 100, yes? So far, you will not be able to solve an equation in which the quadratic term survives, yes? And then they have actually given you a nice problem here, because this 4x squared actually cancels out, yes? I just want to do it in our head, yes? I move x terms to the left without x terms to the right. But when I move this to the left, it becomes negative 4x squared, which will cancel this 4x squared. So this is why I might do that. This is crossed over. Yes? And then what I have to do, I have to move minus 40x to the right, to the left. It becomes positive 40x. And then on the right hand side, I have 1, 2 here, and 100, it's 102. So let me just write it. Yes? And then I move minus 49 to the right, it becomes positive 49. This becomes 40x. This becomes 151. And then I am looking for x, so x becomes 151 divided by 40. And this cannot be simplified anymore. just keep it. Of course, in this case, if you put it in the calculator, that's also an exact value, but that is not necessary at all. So that is the answer. Any questions? It's a good idea also to check the answers so that I haven't done any mistakes. Yes, 151 over 40. Okay, so let me write the next one. I don't know. Was it hard? So because you didn't answer me. Yes, is there something that you don't understand here? No? So okay. So let me write another one here for you. And I want to wait again. Okay, so part C. So part C of the same problem is this. X plus 4 times x minus 4 minus x minus 5 times x plus 5 is equal to 30x. Okay, I want to wait for you here. Again, the people at home, please take notes if you want to write it down, to solve. Okay, so as Ali mentioned and I saw the solution, the answer should be 3 over 10. So let us see if it is true or false. Okay, so here we have to simplify. There is nothing to simplify on the right hand side, but we have to simplify this. And I told you that do not get used to multiplication all the time. Do multiplication when it is not possible to do something else. But here you can recognize two conjugate patterns, yes? One for the first product and another one for the second product. So I open a pair of brackets for expanding this, minus sign, and I open a pair of brackets for expanding this. On the right hand side, I just simply write 30x for the time being. Okay, now this is the conjugate rule, so this becomes the first one squared minus, always minus, the second one squared, which is 16. And here this becomes the first one squared minus the second one squared, which is 25. It's a very, very simple problem, by the way. Now you have to remove pairs of brackets. You don't need to be concerned about this one. Nothing is behind that. So just to simply remove it. But when you want to remove this one, you have to be careful that this minus sign is for all the terms. So it becomes minus x squared. But do not write minus 25. The answer, you have to write positive 25. And on the right hand side, you have 30x. This x squared and then negative x squared are gone. Minus 16 plus 25 is 9. And this becomes 30x. In order to solve the equation, you have to make x alone. So I have to get rid of this factor, so I divide by 30. So this becomes 9 over 30 is equal to x. But don't leave it like that, because 9 is divisible by 3. 30 is also divisible by 3, so do that. So instead of writing x on the right, I write x on the left. This becomes 3 over 10. And that is the answer to this problem. Yes? Okay, so that was actually a little bit of recap about what we have learned so far. But we want to go, at least today I want to start the next lesson. And the next lesson is very, very important. Yes, and that is factorizing polynomials, or factorization. Okay, so factoring. So let me start here, the lesson. This is, by the way, if you do not learn this lesson, then you will be really in trouble for the rest of the math courses. So you have to pay attention to factorization and then you learn it, okay? The good news is that, of course, there are not that diversity of things that you have to learn in the high school level, but so that means that you can master that. So you have only 3 techniques to learn. The first one we will learn today, and there are 2 more. But first of all, let us talk about what is factorization and why that is important. I want to motivate you why we want to factorize something in the first place. First, I want you to appreciate the difference. For example, consider number 12. This number 12 can be decomposed into 2 summands by writing, for example, 10 plus 2. Okay? But I can also write it as a product, 3 times 4. Be careful, the first one, I do not consider it factorization, yes? When I ask you to factorize 12, I mean write something, first of all, equal to 12, and secondly, write it as a product, yes? So this is important. So this 3 times 4 can be considered a factorization of 12. But 10 plus 2, of course, this equality is also true, but we cannot call 10 plus 2 a factorization. So when I ask you factorize an expression or a number, I mean write it as a product. As simple as that, yes? So, but of course here you see that I can continue more. And then every time when I ask you factorize, it means continue factorization process until the very end, that you cannot factorize anymore. So for example, I can write it as 3. Instead of 4, I can write 2 times 2. And if I want to make it more, I have to bring only 1s in. And you don't need to write multiplied by 1, multiplied by 1. So when I ask you factorize 12, I mean to write the 12 as a product so that each one of these, which are called factors, cannot be factorized more. Yes? That is the idea. Is that clear? Yes. So this means that you have to stop with prime numbers. Otherwise, if the number is not prime, it can be written as a product once more at least. So when I ask you to factorize 12, it's this product. For numbers, you already in Maths 1C, I told you a method to do that. You remember, for example, you write 12 here, and then you write 2, it becomes 6. If you divide it by 2 again, it becomes 3, you divide it by 3. And I told you mathematicians has shown that you will always end up with 1, and then these factors are exactly the numbers that appear. But unfortunately, factorization, algebraic polynomials are not that easy at all. We don't have that kind of way. Of course, you might, if you use an algorithm, you can do that, but that is not that easy. So we want only to work with the easy expressions. So is that clear? Yes. So what I want, let me ask you something again. So is this expression that I write a factorized form? No. Yes or no? Yeah, you said yes. Why?
Because they're not been multiplied here.
That's a product, yes. That's a factorized form. If I ask you to read it in English, you say that's a product between x and x plus 1. So that's a product, yes? So it is factorized form, yes, because this expression and that expression are actually multiplied. So the answer, of course, is x squared plus x. So when I ask you to factorize this, one possibility, the answer that you might provide for me is this one. That's correct. Because first of all, this is equal to this one. And secondly, which is important, it's a product. So whenever you have a product which is equal to your expression, that product is a factorization of your polynomial. Is that clear? Yes. Okay. But for example, can I consider this as a factorized form? X multiplied by x plus 1 plus 5. Is it in factorized form?
No.
No. Why?
Because you add 5.
You add 5. So if I ask you read it in English, do you read it as a product or read it as a sum?
Sum.
It is, yes. So if you want to read it in English, you would say that this expression is the sum of this and that. Of course, one part is in product form, but at the end it is not a product, it is a sum. So it means that when you say that this is a sum, it is not in factorized form. That is a rule of thumb. Whenever you have a product, that is a factorized form. Yes, it is extremely important. Pay attention to these details, because I have seen many students, for example, when I ask to factorize this, I have seen many students write equal, and then they write x times x plus 1 plus 5. And then they will get 0 points, not because this equality is false. By the way, this equality is 100% true. But this is not a factorized form of this expression, because that is a sum, not a product. Is that clear? So when I give you a function, any expression, and I ask you to write it in factorized form or factorize it, it means to write an expression equal to that, firstly. Secondly, it should be a product. Is that clear? That's extremely important to understand what is the meaning of a product. But you might wonder why we want to factorize in the first place. Yes? I can give you 2 reasons probably. One reason, we had it already with numbers. For example, if I ask you to simplify this expression, so the reason that you can simplify is because if you factorize this, for example, write it as a product, and write this one as a product, then you see a common factor. By the way, each one of these are called factors of this. So here x is a factor of this expression. X plus 1 is also a factor of this expression. So the factors, so 2 is a factor of 12, 6 is a factor of 12, 3 is a factor of 18, 6 is a factor of 18. Is there any common factor? Yes. So this common factor can be cancelled out, and then what is left for you is 2/3. Of course, this is so simple that might be you don't pay attention to the process in your brain, you immediately write this answer. But that is the reason that we can do that. And be careful about this. Why the product form is better than the sum form. For example, if I have 2 plus 5, and if I have 10, I don't know, plus 7. Okay, so let me even write 5 plus 7. This is important. Can I simplify this 5 with that 5?
No.
No, because first of all, what is the answer? The answer is 7, 12. So this is, by no doubt, this is the answer to this. But if you naively simplify this, the answer that you get is 2/7, which is totally wrong, because the correct answer is 7/12. And that is the reason why the product form is good to have, because then if I have something in common, I can cancel it out. But if I have it in the sum form, even if I have something in common, I'm not allowed to simplify that. Yes? Is that clear? Yes or no? Okay, so it means that one benefit of having expressions in factorized form is that if I have a fraction, which of course appears a lot in mathematics, and I have a common factor, the common factor can be cancelled out. Not the common summand. 5 is a summand of 12 here. 5 is a summand of 7. And then you see that if I naively simplify that, I get 2/7, which is the wrong result. So be careful. That is one reason that we are very interested in factorizing expressions. For numbers, you will not have any problems, hopefully. But I want, for example, in Math 3C, you will start learning simplifying fractions like this, for example. Yes, so that is the reason I want to simplify. Even in matrix, even you might not believe, even in university I see that they make some mistakes in simplifying these simple expressions because they want to simplify x with that x, but that's not possible. So please try to learn this subject very well, because everything from now on more or less somehow is related to factorizing expressions. Okay, so this is the one reason we are interested in factorizing expressions, yes? Another reason is that if I can factorize, so solving polynomial equations is an extremely important part of mathematics, mainly within mathematics itself as well as applications. So it's in many cases, even in applications, in engineering, science, and everything, we have to solve an equation which has the form of a polynomial. For example, if I ask you to solve this equation, we will learn how to solve this equation later. This is a quadratic equation. We will learn a systematic way to solve them later, but assume right now I will ask you to solve this equation. Yes? It's a polynomial, and I have equated to 0, and I want to find the suitable values for x so that this will work. Okay? At this level, you might not know that, but I can give you like this. I can say that, show that x squared plus 5x plus 6 is equal to x plus 2, x plus 3. Okay, this is part 1 of the problem. 2, using part 1, solve x squared plus 5x plus 6 equals to 0. Yes? So I just want you to understand. So for example, the goal is to solve this. Later we will learn a systematic way to do this. But for the time being, I can ask you this question and wait for you to solve this system by giving you this hint. Yes? Let me first of all, is this expression here in the factorized form? It might be it or it might not be, of course. By the way, let me also tell you this. What is the factorization of 7?
1 times 7.
Just 7. Of course, when you say 1 times 7, that's also correct. But 7 is a prime number. I cannot factorize it more. Yes? So this is something similar in polynomials. If I ask you factorize x plus 1, I am asking you to write x plus 1 as a product. Okay, can you imagine how can I write x plus 1 as a product? There is only one way, as here mentioned somehow. What can I do with x plus 1 if I want to write it as a product?
X times 1 plus 1.
No, not x times 1 plus 1. Be careful.
In brackets.
Ah, yes. So yes, that's correct. X plus 1 in brackets times 1. That's the only way. If I really insist to write this as a product, I hope that you agree with me, that's the only way. So this means that x plus 1, I cannot factorize it more. So this is called a prime polynomial. Okay? So I want you to understand, exactly like numbers, some numbers are already in factorized form. They cannot be factorized more. We call them prime numbers. And we have something similar for polynomials. X plus 1, if you want to write x plus 1 as a product, that's the only way. So it means that x plus 1 is already in factorized form. It's a prime polynomial. Yes? Okay. Now, let me go here. Do you agree? First of all, I want to show that this equality is right. That is very simple. Well, how should I do that? Show that this is correct. I have to start from one side, go to the other side, and show that this is true. I would prefer to start from the right-hand side this time, because I know what to do. That's a product, I multiply. So I would say the right-hand side is equal to, I start multiplying things. X times x is x squared, x times 3 is 3x, x times 2 is 2x, and then 2 times 3 is 6. But you see that immediately they are similar, so this becomes x squared plus 5x plus 6, and that is exactly equal to the left-hand side. Yes? Now I am asking you, use part 1 and now solve this equation. Yes? Can I solve that now? The answer is yes. How? Because you say that I want to solve this equation. Yes? But instead of this one, using part 1, I can write x plus 2 multiplied by x plus 3 equals to 0. I hope that you agree with me. There is no difference between this equation and that equation, because in part 1, I showed that this expression is indeed equal to this expression. Yes? But why? Do you think I can now find x values here? What are the values of x? Because this is a product, and the product is which number here? 0. This is not hard to guess. I want to guess numbers so that when I multiply them, it becomes 0. So what does it mean? When the product becomes 0? One of them at least is 0. Yes? So then it means that either x plus 2 is 0 or x plus 3 is 0. But when x plus 2 is 0, it is not at all hard for us to know x. I move 2 to the other side, x becomes negative 2. And then x plus 3, I move 3 to the other side, x becomes negative 3. So you see that even though might be you still don't know a systematic way of solving this equation, but if you give you some kind of this kind of hint in the first part and then ask you to solve the equation, you can solve that. And that is because that's a product. If I give you, so I hope that you agree with me. Can I solve it in this way? I would write it like this. Might be some of you move 6 to the other side and write minus 6. And then write this one as a product. This can be done, yes? Is that understandable? X times x is x squared, x times 5 is 5x, and then equals to minus 6. This is useless. Because I am asking you, can you guess a number so that when I multiply them it becomes minus 6? There are many of them. Yes? So you are not allowed only to consider integers. Because one number might be, I don't know, 36, and the other one would be minus 1 over 6. The product of these two numbers is also minus 6. So you can imagine a lot of possibilities for numbers being multiplied to minus 6. But when the right-hand side is 0, and I have a product form, then I can conclude either this factor is 0 or that factor is 0. Is that understandable? For example, let me make it a little bit harder to see how it goes. I haven't started how to factorize. That would be the topic. I am just motivating you why factorization will be useful in the first place. I gave you two motivations that are important. One was simplifying algebraic expressions that you will study later. And the other one is solving polynomial equations. If I succeed to factorize the polynomial given to me, then I actually can solve the equation. Yes, because of that rule. So for example, let me just start giving you another example to motivate, and then we consider the first trick to how to factorize. Okay. Okay, so here I would say that the goal is this. Let me write part 2. Solve x to the power of 3 plus 6x squared plus 11x plus 6 equals to 0. Yes? I am intentionally writing it this one first. By the way, even if you ask me this to solve that, it's not that easy for me as well. By looking at this equation, you see this is the third degree equation. For the second degree equation, we will study a systematic way to solve it. But for higher degree equations, so this has been proven in mathematics by Norwegian mathematician Abel, actually, that if you go to fifth degree polynomials equations, we do not have a closed formula in general to generate the answers. Okay, so I just want you to know that if you want to solve a higher degree polynomial equation, this could be extremely hard. Okay, and then we have to use approximation methods to find the solutions. Okay, so that's what I want to understand. Even if, because I can solve this right now for you because I just used this scratch paper to generate it myself. So I'm just looking backward. So this is why I can solve it immediately, because I myself designed that, so I know how to go on. But if someone else designed this and gave it to me, it might not be easy for me even to discover how to solve it. I want you to understand that this is a hard problem. Unless I can factorize this. What do I mean by factorizing this? Unless I am able to write this as a product. Then that would be easy. I want you to feel this part. That's the motivation of why factorization is important. This is now, I expect you to be able to solve it. I told you this is a hard problem. But if I give you this hint in the first part, then it is not hard. Okay? I would say that show that, and I want to wait for you to do it for me. Show that x to the 3 plus 6x squared plus 11x plus 6 is equal to x plus 1 times x plus 2 times x plus 3. And then I would say using part 1, solve this. Now this is not hard at all, because the hard part is this one, which is done by the problem and proposed to me. Do you understand the idea? So, first of all, if this is true, we haven't checked that this equality is true, but do you agree that the right-hand side is in the product form? The product of three factors. Name them. The first factor is x plus 1, the second factor is x plus 2, and the third factor is x plus 3. So if I can show this equality is indeed true, then the second part, which was a hard problem in the beginning, becomes a very simple problem now. Okay? I just want to give you a little bit of time to digest this and solve this problem for me. Show the first one and then solve the second one, and then we start learning how to factorize in practice. So the people at home, if you want, you can take notes. Okay, could you solve that? Yeah, so that's a simple problem. So how should I do that? I will start, so let me repeat. If I just give you this is a hard problem. But if I give you this and I ask you to do this, then it becomes simple. Yes? So, I will start from the right-hand side. And then I have to multiply 3 polynomials. So I know that I have to multiply the first two, simplify it, and multiply it by the third one. So I just keep the last one here, and then I start multiplying this by that. X by x is x squared, x by 2 is 2x, 1 by x is x, and then 1 by 2 is 2. I would prefer to simplify and then move on. So this becomes x squared plus 3x plus 2, and then I have x plus 3. And then I multiply once more. Yes? So you see the reason that I am multiplying, we do not have any patterns involved. No conjugate patterns, no expand. So I have to multiply. So then what happens? X squared times x becomes x cubed. X squared times 3 is 3x squared. And then I come here. 3x times x is 3x squared. 3x times 3 is 9x. 2 times x is 2x. And 6. Then I simplify. X to the 3, this one and that one are similar, so it becomes 6x squared. And then it becomes 11x, and then plus 6, and that is exactly equal to the left-hand side. And if you see my scratch paper here, the reason that I knew this, I started from here, multiplied and simplified, then I asked you this. But the point is exactly this. The point is that, you see, this process is trivial. But if you want to do it in the reverse order, it is not trivial. So if I give you 3 factors and I ask you multiply them, more or less everyone can do that by paying attention and just doing a little bit lengthy calculation. But if I give you this and I ask you, can you guess that? That is not hard. That is not easy. And that is the factorization. So you need to be able to do the reverse operation. And the reverse operation in this case could be extremely hard. Yes? Is that clear? I want you to understand, so we are facing a hard problem. But you don't need to be worried because the problems that you have in the book, they are standard, so you don't need to be worried. But factorization is the opposite of multiplication, but it could be extremely hard. And even, of course, for the numbers, that's also the case. Of course, someone proved that this algorithm will work, but that is also harder than just multiplying numbers. Factorizing numbers is harder than just multiplying. Yes? Okay. And by the way, even for computers it is hard, and that's the reason. So every cryptography, actually, credit cards and everything is based on factorizing numbers to prime factors. So this becomes exponentially hard. Even for computers, if the number is so big, factorizing it to prime numbers could be an exponentially hard problem. Yes, so it means that it doesn't matter, even if you have a supercomputer, it might be very, very hard to factorize a number to the factor of prime numbers. Okay. Now we want to solve this equation. Can you tell me what are the solutions? By the way, if I haven't given you this and I ask you to solve this equation, it is not easy even to guess. Even if you guess 1 or 2 numbers, how do you know that these are the only ones? That is important. Even if by coincidence you can find a number that fits this equation, but you cannot claim that you solved the equation. Because when you claim that you solved the equation, it means that I am sure these are the only answers. That is the meaning of solving something. But now I can make sure that I can solve this. Can you tell me what are the solutions?
-1 or -2.
-3, that's it. No more. Yes? Why is that? Because now I can go to the second part. I can go to the second part and try to solve that. But now, instead of this expression, I can replace it with this product 4. So I can write x plus 1 times x plus 2 times x plus 3 is equal to 0. And because the product of 3 numbers can be 0 only if at least one of them is 0. This is not possible, yes? If the product of some numbers is going to be equal to 0, it is not possible unless at least one of them is 0. This is the only possibility. So this means that x plus 1 is 0 or x plus 2 is 0 or x plus 3 is 0. Is there any other possibility? No. Because if this is not 0, this is not 0, this is not 0, I am facing 3 non-zero numbers. And if I multiply 3 non-zero numbers, definitely it is not 0. So it means that this is 0 if and only if one of these happens. So this means that these are the only solutions. So what happens if x plus 1 is 0? When x plus 1 is 0? When x is minus 1. When this is 0, this is minus 2. When this is 0, it is minus 3. So, you see, I was able to solve this equation, but not from scratch. Someone, the designer of the question, gave me this hint, and I was able to solve that. The lesson is that how can I factorize this myself without having that hint? But don't worry, you will not study this. If you are interested, you can see my videos about this on my YouTube channel. But the point is to be able to do this for simple polynomials, not that hard. Yes? Is that clear? Okay, so now I hope that I could motivate you somehow that why factorization is important in the first place. Okay, but I think we can start the first technique here. And this is so trivial, I think you don't need even a teacher to teach you. So let me ask you, I want to test your intuition about it. So if I give you x squared plus 2x, yes? And I ask you to factorize this. Now you understand what is the meaning of this sentence, factorize. This means write this as a product. Okay, can you write it as a product? If you can, it means that you already know how to factorize. You don't need a teacher here. So what can I do here? Yes?
X times the paragraphs x plus 2.
Yes. Everyone agrees that this is a factorization. Why? Two things you need to check. First thing is this equality is really true. Is it true? Yes. Multiply this back. X times x is x squared, x times 2 is 2x. Yes? So that is true, but is it a product form? Yes. It's the product between this as one factor, x. What is the name of the other factor? X plus 2. Yes? So that is the factorization of that. Okay, so for example, if I give you this, can you write this as a product? Yes, huh?
5a plus 2.
5 times a plus 2. Yes? So, what this method is factoring out the common factors. So here, if I ask you, please concentrate here. Let me tell you the name. So, what are the factors for x squared? What are the factors for x squared? Yes? X and x. Yes? Because if you multiply that, this is the factors of x. What are the factors of 2 and 2 times x? 2 and x. Is there something in common between these factors and that factors? Yes. X is in common. You pulled it out. What is left here? 1x is left. What is left here? 2 is left. So this means that you are detecting the common factors and take them out. Okay? So for example, can you write this as a product? Yes?
A plus B.
A plus B. Do you agree? So let me tell you something. How many of you agrees with this? First of all, tell me, is this equality true or false?
It's true.
It's true. Is this a product?
Yes.
Yes. So it means that I have done a good job. I was able to write this as a product. So I have factorized that. But if you stop here, you will lose some points. Because I told you, when I say factorize, it means continue as much as no factor is anymore factorizable. Yes? So if I ask you, what are the factors? You say that A is one factor, name the other one. Is AB plus B squared as a whole. But AB plus B squared can be factorized more. So this is why you shouldn't stop here, because I can pull another B out. Don't do it step by step. Try to find all products. So let me just analyze this a little bit. What are the factors of A squared B? It is A times B. What are the factors of AB squared? It is A times B times B. So what is the common factor? A is in common, B is in common. Yes? So instead of doing it in that way, pull the common factors, all the common factors out. I pull A out because A is a common factor. I pull B out because B is also a common factor. Then I open a pair of brackets. From the first one, only A is left. From the second one, only B is left. Yes? So now, let us check. Is this equality true? The answer is yes, because I really recommend you always to check your answer by multiplying it back in your head. AB times A is A squared B. AB times B is AB squared. And that is a product. The product of how many factors now? How many factors? 3. One of them is A, one of them is B, the other one is A plus B. Can I proceed more? Hopefully you agree with me. I cannot break A, I cannot break B, even I cannot break A plus B. If I want to insist to break it as a product, there is only one way to do that, yes? And I told you that, you don't need to write one. So that is a factorization of A squared B plus this. Yes, I can have more terms, by the way. For example, I can have, so let me go back to the original question. If I give you this to factorize, if someone writes this for me, is it acceptable or not?
No.
It is not acceptable. But is it true or false? The equality is true, so be careful. So some people complain that, okay, this is not wrong, why you have deducted points from me? Because the goal of that question is not to write something equal to that only. Equal and in factorized form, in product form. So be careful about that. So I can have, for example, this scenario. 5x squared y, and then I can have minus 25xy squared, and then I have plus 30xy. Okay, I want to factorize that. Okay, because it is better to rely on your intuition. You need to do the reverse process. Give me something, an expression, so that when I multiply it back, it gives me this. This is not hard. So what is the answer?
5xy.
So you see, I have numbers involved. Do you see the highest common factor between 5, 25, and 30? It is 5. So 5 is a good option to pull out. Now I have x squared here, 1x here, 1x here. So what is the highest power of x in common? 1, yes? Because this, of course, this contains 2 x's, but this one and that one only contain 1x. So that x is the only highest power of x that I can pull out. What about y? The same thing. Agree? So I pull a y out as well. So can you tell me what is left in the pair of brackets?
xy.
From this one, 5 is pulled out, y is pulled out, x is pulled out. So what is left? Only 1x is left. Yes? By left, I think it's a little bit confusing. You have to divide this in your head by the factor that you pulled out. So that is x is left. And then this is negative. I put negative sign here. I divide 5 by 5, it is 5. I divide x by x, it is 1. I don't need to write 1 because 1 times 5 is 5. I divide y squared by y, it is y. So I write this. Okay, can you tell me the last term?
6.
Plus 6. And this is the factorized form of this polynomial. Is that clear? Okay, so these techniques, we only learned 3 of them in high school. If you are interested, you can watch the videos on my YouTube channel if you are interested in solving harder problems. But at this level, it is not hard at all. This is the first technique. The second technique is to use the squaring rule And the third technique will be using the conjugate rule. That's the only rules that you need to know for factorizing the polynomials at high school level. Any questions so far? Okay, we stop here. I will update the Google Classroom in a while. I think you have still some time. Don't waste it. Try to work. By the way, the factorization is finished. When it is finished, I give you a little bit of time to practice. Then we will have our second test. Of course, we will decide about the date and time, and that will be only algebra. Of course, I promise you to write it down. When I am getting close to the exam, I will write it down. Okay? So I mean that we are not that far away from the second exam. After I told you two other methods for factorizations, this chapter is finished. Let me see. Yes, this chapter is finished after that. And then, of course, we will decide together about the suitable date for the exam. Yes. So I just want to make sure that you know that very soon we will have the second test. Let me stop recording the video and then I will answer you. Is that related to the question here?
Related to the exam.
Okay, so let me just stop recording it. Thank you.